Imagine this, a message that defies the laws of physics as we know them. It doesn't just cross distances in the blink of an eye, it transcends time itself. A system so advanced, so incomprehensibly fast, it leaves our most sophisticated technologies in the dust. Now ask yourself, what if this system already exists? What if it's been operating in secret, linking civilizations across eons and light years? For decades, physicists have whispered about particles known as tachyons. These are no ordinary particles. They don't obey the same rules as the rest of the universe. While light speed is the ultimate limit for everything we know, tachyons break that limit effortlessly. They aren't bound by the constraints of time and space. If tachyons are real, they could be the perfect carriers for a communication network that not only spans galaxies but also bridges the past and the future. Now let's turn our gaze back to Earth, our own history. Human progress is full of inexplicable leaps, moments where knowledge seems to appear out of nowhere. How did ancient cultures, isolated by oceans and continents, develop eerily similar architectural techniques, astronomical knowledge, and myths? Why do we find advanced artifacts, like the Antikythera mechanism, in times when such complexity shouldn't have existed? Could it be that we've misunderstood the nature of these advancements? What if these breakthroughs weren't the result of genius alone, but of information, shared across a network we can't see, touch, or even measure? A network powered by tachyons, transmitting knowledge faster than light, perhaps even from distant civilizations we've never known. And here's the twist. If such a network exists, why aren't we all aware of it? Could it be hidden? Controlled? There are whispers of governments and secret organizations delving into this field, their research locked away behind classified files and unmarked doors. What if the discovery of tachyons isn't new but something that's been uncovered, used, and suppressed? Its potential too great, too dangerous to share with the world. In 2019, Google's Sycamore quantum computer achieved what was once thought impossible, solving a complex problem in mere minutes that would have taken classical computers thousands of years. By 2024, a new quantum milestone was reached with Willow, a machine so powerful it could simulate the very fabric of reality itself. If quantum computing is already rewriting the rules of our universe, how close are we to unlocking tachyon-based communication? But let's not forget, every great discovery comes with a cost. Who controls this technology if it exists? And more importantly, who benefits? Are tachyons simply theoretical curiosities, or are they the hidden threads of a network that has shaped our history and might determine our future? Think about the sudden rise and fall of advanced civilizations. Atlantis, the Indus Valley, the Maya. Legends tell us of lost technologies, of knowledge that vanished without a trace. What if these civilizations weren't lost at all but cut off from the network? What if their knowledge wasn't destroyed but buried, waiting for someone to rediscover the signal? In this video, we're diving deep. We'll explore the science of tachyons, their strange, almost magical properties, and the theories surrounding their potential. We'll connect the dots between ancient myths, groundbreaking modern discoveries, and tantalizing hints of a hidden communication network. We'll uncover the stories, the anomalies, and the possibilities that will challenge everything you thought you knew about the limits of science and human history. The Tachyon communication network could be the key to understanding not just the mysteries of the past, but the fate of our species. So ask yourself, if such a network exists, who, or what, is already using it? And what does it mean for us if they're not human? This is the story of a secret that could change everything. Let's uncover it together. To understand the Tachyon communication network, we must first dive into the origins of the idea itself, a story rooted in both scientific theory and tantalizing mysteries from our distant past. Tachyons, as a concept, emerged in the 20th century, introduced by physicist Gerald Feinberg in 1967. Feinberg theorized the existence of these faster-than-light particles, naming them after the Greek word tachy, meaning swift. Tachyons didn't just challenge our understanding of physics, they dared to defy Einstein's theory of relativity, which declared that nothing could exceed the speed of light. Here's where it gets interesting. According to Feinberg's work, tachyons could theoretically carry information faster than light, creating a channel through which messages might be sent across space and time. This wasn't just a whimsical notion, it was grounded in rigorous mathematics. Yet even as the scientific community debated the existence of these particles, others began asking, what if tachyons weren't just a possibility but a reality? And what if they've been in use far longer than we imagine? Now let's go back thousands of years. The great civilizations of antiquity, Atlantis, the Mayans, the Indus Valley, produced technologies and knowledge that continue to baffle modern scholars. The pyramids of Giza, for instance, align with extraordinary precision to the cardinal points and celestial bodies. The Mayans devised an intricate calendar more accurate than anything in Europe for centuries. In the Indus Valley, evidence of sophisticated urban planning and water systems suggests a civilization far ahead of its time. Could these feats of engineering, astronomy, and mathematics have been achieved with nothing more than intuition and trial and error? Or is it possible that these cultures access knowledge from an external source, one beyond our current understanding? Some researchers argue that their advancements bear the hallmarks of communication with a far superior intelligence. Could tachyons, and the network they may enable, be the missing link? The Cold War era added a new layer of intrigue. As the US and the Soviet Union raced to outmatch each other in technology and intelligence, secret projects flourished in both nations. Declassified documents reveal efforts to develop advanced communication systems, some involving speculative physics. Could these projects have touched upon tachyon theories? And if so, did their findings remain hidden, locked away under the guise of national security? One chilling possibility is that these governments discovered the potential of tachyon-based communication, but deemed it too powerful to disclose. Imagine the implications of instantaneous, untraceable communication, spying without detection, controlling narratives in real time, even sending messages into the past to alter outcomes. If such technology existed, it would be the ultimate weapon, a tool capable of shaping history itself. As the Cold War ended, the world shifted its focus to quantum computing, a field that might hold the key to unlocking tachyon communication. In 2019, Google's Sycamore quantum computer demonstrated quantum supremacy, solving a problem exponentially faster than any classical computer. Then came Willow, a quantum computer that broke new ground in error correction, bringing us closer to flawless quantum systems. But here's the question. Could these breakthroughs also be stepping stones toward harnessing tachyons? And if tachyons have been theorized for decades, why is there still so little public knowledge or evidence of their use? Could it be that the discoveries have been deliberately suppressed, hidden away for fear of their implications? Or could it be that the signals themselves are too faint, too subtle for our current technology to detect? As we unravel the threads of this mystery, we'll explore how ancient knowledge, secret Cold War projects, and quantum computing might converge to reveal the existence of a tachyon communication network. The deeper we dig, the clearer it becomes. This isn't just a story about science. It's a story about control, of knowledge, of power, and possibly of reality itself. What secrets are hidden in the fabric of time and space? And how long have we been using, or being used by, a network we can barely comprehend? To unravel the mystery of the tachyon communication network, we need to delve into the science behind these enigmatic particles. At first glance, tachyons seem like they belong more in the realm of science fiction than science. Yet their theoretical properties are rooted in the rigorous equations of modern physics, equations that challenge our understanding of reality. In essence, tachyons are hypothetical particles that travel faster than light. But what does this actually mean? In the framework of Einstein's theory of relativity, nothing can surpass the speed of light without requiring infinite energy. Tachyons, however, flip this logic on its head. With a property known as negative mass, tachyons are not slowed by resistance. Instead, they accelerate as they lose energy. Imagine an object moving faster and faster as it expends less effort. a concept so counterintuitive it almost feels impossible. But physics doesn't dismiss impossible ideas. It studies them. Theoretical physicists have used tachyons to explore mind-bending phenomena like time reversal. If tachyons exist, they could theoretically send information backward in time. A message transmitted today might arrive yesterday. Think about the implications. Instantaneous communication across vast distances is one thing, but sending a warning or a command into the past, that's something else entirely. However, there's a reason tachyons remain theoretical. Detecting them poses enormous challenges. Their faster than light speed places them beyond the reach of conventional instruments, while their negative mass defies the parameters of existing technology. Critics argue that tachyons are purely mathematical constructs, a quirk of equations rather than a reality. But isn't that what they once said about black holes? Modern science, particularly quantum mechanics, provides tantalizing parallels to tachyon theories. Take Google's Sycamore quantum computer, which proved that certain problems could be solved exponentially faster using quantum bits, or qubits. Unlike classical bits that are either 0 or 1, qubits can exist in multiple states simultaneously, a phenomenon called superposition. Could tachyons operate similarly, existing in a state that transcends our usual understanding of space and time? Enter Willow, the quantum computer unveiled in 2024. Willow's breakthrough wasn't just its power, it was its ability to perform advanced error correction, eliminating the noise that plagues quantum systems. In a sense, Willow created a clearer signal, a leap forward in communication technology. Now imagine if tachyons, with their faster-than-light capabilities, could be paired with a quantum computer like Willow. What kind of network could we build? Here's one theory. Tachyons might function as communication carriers, much like radio waves or fiber optics, but on a cosmic scale. Instead of relying on photons, which are constrained by light speed, this hypothetical network could use tachyons to transmit data instantaneously. Quantum entanglement, another phenomenon where particles are mysteriously connected across distances, could serve as the infrastructure, creating a lattice of faster-than-light communication channels. But it gets stranger. If tachyons can move backward in time, the possibilities multiply. Imagine a network where messages not only traverse the stars but also span timelines. Decisions made in the present could influence the past, altering outcomes in ways we can't even begin to predict. The consequences would be profound, even dangerous. And yet, the clues are already here. Scientists have detected strange, unexplained phenomena, fast radio bursts, FRBs, that last mere milliseconds yet release as much energy as the sun does in a day. The mysterious WOW signal detected in 1977, a 72-second burst of radio waves from deep space. Are these anomalies the result of natural astrophysical processes, or are they the echoes of a tachyon communication network, fragments of a signal we don't yet understand? The science of tachyons is as much about possibility as it is about proof. While mainstream physics remains skeptical, history shows us that today's impossibilities often become tomorrow's breakthroughs. Could tachyons be the next step in humanity's understanding of the universe, or have they been here all along, waiting for us to catch up? The key lies not just in theory but in application. How do we bridge the gap between what we suspect and what we can prove? And if such a network exists, what secrets might it already be carrying? The answers, as always, may depend on how far we're willing to look. What if the tachyon communication network isn't just a futuristic possibility, but something that has already existed, perhaps for millennia? To explore this idea, we must look to the legends of advanced civilizations that have captivated humanity for centuries. Atlantis, Lemuria, and others like them have often been dismissed as myth. But what if these stories were more than just ancient fables? What if they hinted at a lost technology capable of transcending the barriers of time and space? Atlantis, for example, is described by Plato as a powerful civilization possessing technologies far beyond its time. According to legend, it vanished beneath the waves in a single catastrophic event. But what if Atlantis didn't just disappear? What if its destruction was tied to its mastery of an advanced communication system, a network so powerful that it may have disrupted the balance of their world? Consider the synchronicities across ancient cultures. The pyramids of Egypt, the ziggurats of Mesopotamia, the temples of the Maya. All these structures align with celestial phenomena in ways that suggest a deep understanding of astronomy. More intriguingly, they share strikingly similar architectural features, despite being separated by vast distances and time periods. Could these structures have been part of a global Tachyon network, nodes designed to transmit information across the planet? Let's take it a step further. In the Indus Valley, researchers have found evidence of advanced urban planning and mathematical systems that rival those of modern times. The Mayan calendar, too, demonstrates an astonishing grasp of time cycles. Were these civilizations working from a shared source of knowledge, a network that connected them in ways we can't yet explain? Now let's fast forward to the Cold War. This was an era not only of political tension, but also of technological obsession. Both the United States and the Soviet Union poured resources into developing cutting-edge communication systems. Declassified documents hint at experiments involving exotic particles and theories that veered into the speculative, even the absurd. Some claim that secret projects like the US government's Project Stargate or the Soviet psychotronics program may have brushed against the edges of Tachyon theory, perhaps even uncovering evidence of its feasibility. But here's where it gets even murkier. What if the anomalies we attribute to UFOs and extraterrestrial encounters aren't alien at all? What if they're tied to this network? Reports of strange craft moving at impossible speeds, defying the laws of physics, could be connected to the use of tachyons as a propulsion or communication mechanism. Are these sightings evidence of civilizations, hidden on Earth or elsewhere, still using the network? Let's not ignore the role of secrecy. If governments or other organizations have uncovered the potential of tachyons, their first instinct would likely be to suppress it. A tachyon-based communication network could upend everything: economic systems, geopolitical power structures, even our understanding of time and causality. In the wrong hands, it could be weaponized, used to manipulate history or intercept future events. Now let's circle back to the idea of hidden civilizations. Could they still exist, cloaked from our perception by the very network they once built? Some conspiracy theorists argue that subterranean cities, like the rumored Agartha, or underwater civilizations, like the supposed ruins off the coast of Japan's Yanagani Monument, might be remnants of these lost cultures. If these civilizations survived, they might still be communicating, quietly, in a language we don't yet understand. And then there's the possibility that we've already intercepted fragments of this communication. Signals like the 1977 WOW signal, fast radio bursts, and other unexplained phenomena might not be random after all. Could they be messages sent across a tachyon network, intended for civilizations more advanced than ours, or perhaps even for us, if only we knew how to listen? Theories of hidden civilizations remind us of the gaps in our understanding of history. If tachyons have been harnessed before, then the technology isn't just theoretical, it's lost. And if it's lost, what does that mean for humanity's future? Are we rediscovering an ancient technology that could reconnect us with our past? Or are we stumbling into something far beyond our comprehension? These questions lead us to the next step in our journey: how such a network could actually work. Could today's quantum breakthroughs hold the key to rediscovering what ancient civilizations may have known all along? Or are we on the verge of creating something entirely new, standing at the threshold of the unknown? If a tachyon communication network exists, or could exist, how would it actually function? This is where cutting-edge science and speculative theories intertwine, offering glimpses into what might be possible if we harnessed the power of tachyons. First, let's consider the infrastructure. Unlike our current communication networks, which rely on satellites, fiber optics, and radio waves, a tachyon network would be fundamentally different. Tachyons, with their ability to travel faster than light, wouldn't need physical mediums or even line-of-sight transmission. Instead, they could form instantaneous connections between points across vast distances, bypassing the limitations of traditional technology. Imagine sending a message from Earth to the farthest reaches of the galaxy, not in years, but in milliseconds. But here's where it gets truly fascinating. Tachyons, if real, could potentially transmit information not just faster than light, but backward in time. This isn't just science fiction, it's a direct consequence of their theoretical properties. In such a system, communication wouldn't be constrained by causality. A message sent into the future might already have been received in the past, creating a feedback loop of information exchange across time itself. How could this work in practice? One hypothesis involves quantum entanglement. In quantum mechanics, entangled particles share a connection so profound that a change in one instantaneously affects the other, no matter the distance between them. If tachyons could be integrated into such a system, they might act as the ultimate carriers for entangled qubits, forming a communication network that transcends space and time. Now, let's think about the hardware. Modern quantum computers like Willow are already pushing the boundaries of what's computationally possible. Willow's groundbreaking achievement in error correction allows quantum systems to process information with unprecedented clarity. What if this same principle could be applied to tachyons? Theoretically, a tachyon-based network could integrate quantum computing to manage, interpret, and secure its transmissions, creating a system that operates with flawless precision. But how would we encode and decode tachyon signals? This is where speculative mechanics come into play. Tachyons might interact with the quantum fields that permeate the universe, using fluctuations in these fields to carry data. Alternatively, they could be manipulated through controlled energy states, with each state corresponding to a piece of information, a kind of tachyonic Morse code. And what about the practical implications? A tachyon network could revolutionize everything. Global communication would become instantaneous, eliminating delays in everything from financial transactions to military operations. Space exploration would reach new heights, as probes and spacecraft could maintain real-time communication regardless of their distance from Earth. Scientific collaboration could take place across the universe, unhindered by the constraints of light-speed communication. But there's more. If tachyons allow backward communication in time, the implications extend beyond technology. Imagine receiving a warning about an impending disaster before it occurs. Imagine historians uncovering the true stories of ancient civilizations through messages sent from the past. Imagine a world where decisions aren't just informed by foresight but by hindsight, messages from the future guiding the present. Of course, such power would come with profound risks. Who decides how the network is used? Could it be exploited to alter timelines, erase events, or rewrite history? Could it become a tool for control, wielded by a select few at the expense of the many? Even more unsettling is the question of interception. If tachyon signals can cross both space and time, who or what might already be listening? Could extraterrestrial civilizations have created this network long before we even considered it? Could we be tapping into a system that has existed for eons, a cosmic internet built not for us but by others? Real-world anomalies already fuel speculation. The WOW signal, detected in 1977, remains one of the most compelling pieces of evidence for extraterrestrial communication. Fast radio bursts, FRBs, with their mysterious origins and patterns, continue to baffle scientists. Are these phenomena natural, or are they the echoes of a tachyon network in action, signals sent by advanced civilizations that have already mastered the technology we're only beginning to imagine? As we explore the mechanics of this hypothetical network, we must confront a sobering truth. If such a system exists, we may not be its creators, but its inheritors, or even its intruders. The question isn't just whether we can build this network, but whether we're ready for what it might reveal. Stay with us as we delve into the stories and anomalies that might point to the existence of this mysterious communication network. Could the evidence already be all around us, hidden in plain sight? Let's find out. Throughout history, humanity has encountered mysteries that defy explanation. Strange signals, forgotten technologies, and uncanny synchronicities have captured our imagination and left us questioning the nature of our reality. Could these events be fragments of evidence for something far greater, a hidden Tachyon communication network linking civilizations across time and space? In ancient Greece, the Oracle of Delphi stood as the conduit between the mortal and divine. Priests and priestesses claimed to channel messages from the gods, messages that shaped the destinies of kings and empires. But what if these weren't divine whispers at all? What if they were the earliest recorded instances of humans unknowingly interacting with a tachyonic system, a means of accessing knowledge beyond their understanding, delivered by signals we still cannot comprehend? Ancient Indian texts, like the Mahabharata, describe celestial chariots known as vimanas, vehicles capable of traversing the skies and even traveling to other realms. These descriptions, rich in detail, sound eerily similar to modern accounts of spacecraft, or perhaps something even more advanced, powered by technologies we are only beginning to theorize. Could the vimanas have been real? And if so, did they rely on a hidden communication network to navigate their extraordinary journeys? Consider the biblical story of the Tower of Babel, a structure built with the intent to reach the heavens. Its destruction and the subsequent division of languages are often interpreted as divine punishment. But what if it was something else entirely? What if the tower symbolized humanity's attempt to access a universal communication network, a network so powerful it threatened to collapse the delicate balance of civilizations? These questions are not limited to ancient history. In the modern age, our encounters with the unexplained continue. In 1977, astronomer Jerry Amon recorded a powerful, unexplained signal from deep space while working on a project to detect extraterrestrial intelligence. This signal, later named the WOW signal, lasted for 72 seconds and has never been detected again. Its precision and intensity were far too specific to be random noise. Was this a fleeting fragment of a tachyonic transmission, a message intended for a recipient who, perhaps, wasn't us? Fast radio bursts, or FRBs, are another enigma. First discovered in 2007, these intense flashes of radio energy originate from distant galaxies and last only milliseconds. Some repeat in patterns while others occur only once. Their origins remain a mystery, but their power and precision suggest something extraordinary. Could these bursts be the byproducts of tachyonic communication, fragments of data coursing through a network we don't yet understand? The military has its share of unexplained incidents as well. During the Cold War, strange green fireballs were frequently observed near U.S. military installations. These objects moved with impossible precision, displaying behaviors that defy the capabilities of known technology. Were these sightings connected to a hidden tachyonic network, or perhaps to vehicles powered by tachyon propulsion systems? Even more intriguing are accounts of anomalous transmissions intercepted during this era. Cryptic signals, unknown languages, mathematical sequences, or bursts of static encoded with patterns, were picked up by intelligence agencies. These signals were often dismissed as interference or enemy transmissions. But what if they were accidental glimpses into a tachyonic network, carrying messages far beyond our comprehension? Modern advances in quantum computing have added fuel to the fire. Willow, the revolutionary quantum computer unveiled in 2024, pushed the boundaries of what machines can accomplish. Its ability to simulate natural processes with uncanny accuracy has led some theorists to wonder, could such systems inadvertently tap into a tachyonic communication network? Could Willow's algorithms be decoding signals sent from elsewhere, perhaps even from another time? The amateur scientific community has also stumbled upon anomalies. In 2020, a hobbyist radio astronomer in Australia detected a repeating signal from Proxima Centauri, the closest star system to Earth. Official explanations dismissed it as interference, but the signal's precision raised questions. Was it simply a fluke, or an intercepted transmission from a tachyonic system used by an advanced civilization. Even NASA has encountered unexplained phenomena. The Pioneer and Voyager missions, which sent spacecraft hurtling into interstellar space, occasionally reported anomalies in their trajectories and communication signals. These deviations, though subtle, hint at forces we don't fully understand. Could these anomalies be evidence of tachyonic interference, or even attempts at communication? When viewed individually, these stories might seem like isolated curiosities, coincidences with no connection, but together they form a pattern, one that points to the existence of a hidden network capable of transmitting information across unimaginable distances, and perhaps even through time itself. If these signals and events are echoes of such a system, what does that say about the source? Who or what is sending these messages? Are we the accidental recipients of a communication system built by others, or are we uncovering the remnants of a network that once connected lost civilizations? And if this network still exists, how much of it is already known to governments, institutions, or entities that prefer to keep it hidden? These questions demand answers, but they also raise an even more profound question. If we are only now beginning to detect these signals, what else might we discover when we finally learn how to listen? The idea of a Tachyon communication network is undeniably tantalizing. It promises to unravel the mysteries of the cosmos, connect hidden civilizations, and even transcend the limits of time itself. But not everyone is convinced. Mainstream science, historical skeptics, and logical analysis provide a necessary counterbalance to these extraordinary claims. After all, extraordinary claims require extraordinary evidence. To start, let's address the scientific criticisms. Tachyons, as compelling as they are in theory, have no direct empirical evidence to support their existence. Their properties, faster than light travel, negative mass, and the ability to move backward in time, are derived from mathematical models that remain speculative. Critics argue that these models, while fascinating, may be nothing more than elegant thought experiments. The challenges of detecting tachyons are immense. Their very nature places them beyond the reach of conventional instruments. Some physicists even question whether they're physically possible, given that their existence would violate the principle of causality, the fundamental idea that cause precedes effect. Then there's the issue of historical interpretation. Ancient technologies, such as the pyramids or the Antikythera mechanism, are often cited as evidence of advanced knowledge beyond the capabilities of their time. But skeptics counter that these achievements, while impressive, can be explained without invoking tachyons or hidden networks. The alignment of the pyramids with celestial bodies, for instance, may reflect the ingenuity of human observation and a deep understanding of astronomy, rather than the influence of an external communication system. Similarly, stories from ancient texts, like the Vimanas of Indian epics or the Tower of Babel, are often dismissed as mythological allegories rather than historical accounts. Critics argue that interpreting these stories as evidence of a tachyon network imposes a modern lens on ancient narratives, distorting their original meanings. Modern anomalies, like the wow signal or fast radio bursts, also face scrutiny. While their origins are mysterious, many scientists attribute them to natural astrophysical phenomena. The wow signal, for instance, may have been caused by an overlooked terrestrial source, and far Bs could result from neutron stars or black holes. Without repeatable evidence or clear patterns, skeptics caution against jumping to conclusions about their connection to tachyonic communication. Quantum computing, often heralded as the frontier of human ingenuity, also faces limitations. Machines like Willow have undoubtedly achieved remarkable feats, but their capabilities remain firmly grounded in established physics. The suggestion that quantum computers could inadvertently tap into a tachyonic network is, at best, speculative. While quantum entanglement and superposition defy classical intuition, they do not inherently imply faster-than-light communication or time reversal. There's also the question of conspiracy theories. Claims that governments or secret organizations have discovered and suppressed tachyon technology are compelling but lack verifiable evidence. While it's true that classified research exists, particularly in military and aerospace sectors, there's no concrete proof that tachyons are part of these projects. Skeptics argue that the allure of secrecy often leads to overinterpretation, where mundane projects are imbued with extraordinary meaning. Despite these criticisms, it's worth noting that science has a history of dismissing ideas that later proved revolutionary. Black holes were once considered mathematical curiosities, not physical realities. The concept of quantum mechanics was met with fierce resistance in its early days. Even the idea of a round Earth, now a cornerstone of our understanding, was once ridiculed. Could tachyons and their potential networks follow a similar trajectory? While skeptics rightly demand rigorous evidence, they don't entirely dismiss the possibility of tachyons. Some suggest that if tachyons exist, their effects may be so subtle that current technology cannot detect them. Others argue that our understanding of physics is incomplete, and tachyons might fit into a framework we have yet to discover. Ultimately, skepticism is not a dismissal. It's an invitation to explore further. The gaps in our understanding are where breakthroughs often emerge. What if the skeptics are right, but only for now? What if the missing evidence is just waiting to be uncovered, lying dormant in signals we've yet to decode or experiments we've yet to conduct? As we consider these counter-arguments, we're left with a profound question. Even if tachyons remain theoretical, does that diminish the value of exploring their potential? History shows that the greatest advancements often begin with ideas that seem impossible. Could this be another such idea? Could the future of humanity hinge on whether we dare to look beyond the skepticism and into the unknown? Throughout this journey, we've explored the tantalizing possibility of a tachyon communication network, a system that could defy the limits of time and space, link hidden civilizations, and revolutionize our understanding of the universe. We've delved into ancient myths, modern anomalies, cutting-edge science, and skeptical critiques. And yet, one truth remains. We are left with more questions than answers. If such a network exists, it would be the ultimate game-changer. Imagine a system capable of transmitting not just information, but knowledge, instantly, across galaxies, and even through time. The implications are staggering. Could it explain the unexplainable? The rapid bursts of innovation in human history, the synchronicities between ancient cultures, the sudden rise and fall of advanced civilizations, are these coincidences, or could they be evidence of a hidden network at play? But even as we speculate, we must grapple with the unknown. Are tachyons real, or are they just a mathematical curiosity? If they are real, who or what might already be using them? Could a network like this have existed long before us, built by civilizations far more advanced? Or are we on the brink of discovering something entirely new? Something that will rewrite the rules of communication, power, and even reality itself? Then there's the question of control. If such a network exists, who holds the keys? Is it the domain of governments, secret organizations, or extraterrestrial intelligences? And what does that mean for the rest of us? Would the existence of such technology unite humanity, or would it create new divisions, new conflicts, as we struggle to wield its power responsibly? The skepticism we've explored serves as a reminder of the challenges ahead. Science demands evidence, and rightly so. But history has shown that today's impossibilities often become tomorrow's breakthroughs. Black holes, quantum mechanics, and the very fabric of our reality were once dismissed as fantasy. Could tachyons and their potential networks be the next great leap? As we close, one question lingers. If a tachyon communication network existed, would we even recognize it? What if the signals are already here, hidden in plain sight, waiting for us to tune in? And if we do uncover such a network, what secrets will it reveal about our past, our present, and our future? This is more than a story about particles or physics. It's a story about the human spirit, our relentless curiosity, and our quest to understand the universe. Whether the tachyon communication network is a reality or a possibility, It challenges us to look beyond the known and embrace the mystery of the unknown. So, where do we go from here? That's up to you. The search for truth doesn't end here. It begins with the questions we dare to ask. If a network exists, connecting civilizations across time and space, who might already be listening? And more importantly, what are they waiting for us to discover?